Hello, everyone. My name is Gitika, and today I am very honored and excited to be interviewing a very special space champion, Dr. Jessie Christiansen. Dr. Christiansen is an Australian astrophysicist working at the NASA Exoplanet Science Institute at Caltech. She won the 2018 NASA Exceptional Engineering Achievement Medal for her work on the Kepler planet sample. Receiving a degree in physics and mathematics at Griffith University and completing her PhD at the University of South Wales, Dr. Christiansen then worked as a postdoctoral research fellow at the Harvard-Smithsonian Centre for Astrophysics. Additionally, she is a science communicator and speaks at academic conferences and appears on some cool shows like the Discovery Science program, NASA's Unexplained Files. I'm so excited to be able to talk with Dr. Christiansen on her journey and what really made her passionate about space. So thank you so much. Welcome, and thank you for taking your time to do this interview and to inspire the next generation.
Well, thank you so much for having me, Gitika. I'm really excited to chat.
Yeah, before we get into understanding your journey and what really led you into the industry, could you tell us more about your typical day? How does it usually run?
Sure. So my position is I'm the project scientist of the NASA Exoplanet Archive, which is how NASA keeps track of all of the exoplanets we found, which is planets around other stars. And we found over 4,500 of them so far. So my role is basically to guide the science, to identify the planets, to work out what properties we should keep, to help develop tools to manipulate the data and visualize the data. So that's really fun. And, it's really exciting to get to keep track of this really, hot field in astronomy, which is exoplanets. The other half of my day is my research. So what I do is look for new exoplanets. So I use data from the NASA Kepler mission, the NASA K2 mission, and the NASA TESS mission to look for new planets around other stars. And I'm really excited right now. I'm working on a big paper with something like 50 new planets in it, which is pretty cool.
Wow, that is incredible. Just kind of like half your day dedicated to discovering. I think that's exactly why everyone wants to go into, research, just to be able to explore. And I'm curious because I'm not too knowledgeable about exoplanets. Could you tell us how you specifically identify or factors you look into exploring new exoplanets?
Yeah, so there's a few different ways of finding exoplanets. The one that I use with these 3 NASA missions is called the transit method. And so if you imagine this big black circle behind my head is a star and I'm a planet, basically you monitor the brightness of the star, and as the planet comes in front, it blocks some of the brightness. So what you see, we don't actually ever see the planet, but what we see, if you were plotting the brightness with time, you see a little dip as the planet goes in front. So all we do, it's a very boring measurement. We just measure the brightness of stars over and over and over and over again and wait for little dips to happen.
Wow, so you must have been really observant, and you always have to pay attention to the numbers. And so I've heard and I've read kind of a few papers how there's theories of planets that seem to have similar atmospheric conditions or like the mass as Earth does. Do you think that there's a similar exoplanet out there that has similar conditions to Earth?
We really think that there are Earth-like planets out there. It's interesting because we haven't found any yet. But basically what we saw with Kepler, so the whole point of Kepler was to measure how common planets like the Earth might be. What we saw was that as you got nearer and nearer to Earth in 2 different important properties, one is distance from the star. So, Earth takes 365 days to go around our sun. So one is distance from the star, and the other one is the size of the planet. So with the Kepler data, as you got further out from the stars that we were looking, and as you got smaller and smaller, you saw more and more and more and more planets. So unfortunately, it turns out the sensitivity of our instrument wasn't good enough to really get to Earth-like planets, but we don't have any reason to believe that trend, that planets seem to increase in occurrence with size and distance from the star, would stop before you get to Earth. So we actually think that there are lots and lots of Earth-like planets out there. Now, whether they look like Earth beyond these bulk details, like a rocky planet that takes something like 365 days to orbit its star, we don't know yet. But launching things like the James Webb Telescope next month and the Roman Telescope in a few years is how NASA will really find out.
Yeah, and that's why I'm really, really excited, just like the unknown and how we can't say definitively that, oh, there's no other planet like Earth. We just don't know. And that's what I love about space. And so kind of diving a little bit into your specific research, I know this is a really tough question to ask a researcher or a scientist, but if you had to pick one project, what is your most exciting project or research that you have worked on or are currently working on?
I mean, it really is this search for Earth 2.0. So, I feel like we got kind of stymied with Kepler because we found thousands of planets and we found small planets and we found planets that were far away from their star, but we didn't find small planets that were far away from their star. So it's just so close. So that quest continues. That's kind of like the holy grail for many exoplanet researchers, is finding a planet like the Earth.
Wow. And do you work with young students, maybe at Caltech or others in the industry, to be able to, find solutions and think creatively together?
Yeah, I actually have some really excellent students in my group. One is at UCLA. She's a master's student. She's got this really interesting background where she's done architecture and urban design and urban planning. And now she's really interested in space and space science and space resources. So what she's thinking about is, what will settlements on the moon look like, right? She's taking her cool urban planning background and saying, like, what do we do in space? How do we design things in space so that, we obey all these principles of urban planning, but, live in the harsh environment of space? So that's really cool. And then I have another student who is applying to grad schools right now, and I'm hoping that she gets in because she's doing a really excellent job. She's helping me confirm some of these 50 planets that I mentioned.
Wow. And, do you, when working with these students, come up with new ideas, like some new perspectives that you might have not thought of before?
Yeah, for sure. I think that, every generation of researchers comes in with different biases and different preconceived notions. So the students today, they've had so much software available to them, just libraries and libraries of software, that they have this really interesting, I'm like, oh, we're going to have to solve this problem, let's go back to the equations and work out, wow. And they'll just be like, oh, someone else already wrote a package that does this, let's do it. And it's like, oh, we can skip that whole step and move on to this analysis. So that's, just that little mindset change of like, wait, there's so much software that's been made publicly available. And that's one of the really interesting, sea changes in the field. It used to be, over the last 50 years, that people were very private with their data and their code and their analyses. Like, they would publish results, but the actual code that they ran, they wouldn't share because they'd invested a lot in it. It was basically like building a new instrument. So people wouldn't be as open with it. But now there's been this real change where the culture is much more that you share your software and you make it publicly available and you document it and you support it. And now the challenge is, because everybody thinks this is great. Obviously, we don't all have to rewrite the same Python code 10 times or 100 times. The challenge now is to get the value system of the field to recognize that, because there's this problem where people put a lot of effort into software, but software papers don't get cited a lot. They don't really get a lot of credit when you're, going for a promotion or going for tenure or going for some kind of prize. And that's just because the way we measure how valuable people are in the field hasn't caught up with the fact there's been this big change in the last 20 years towards really, focusing on open source software.
Yeah, of course. And, another question that popped into my mind while you were speaking is when you were talking about different, perspectives and ideas, was a lot of students are interested in astrophysics or planets and, aliens, and they want to sometimes go into the specific field of astrophysics or exploring exoplanets. So would you say that there is only one path to get into where you are today? Or do you think that there's multiple degrees that could really contribute to the study that you're a part of?
Oh, yeah, absolutely. There's multiple degrees. So for instance, you mentioned earlier you're interested in the biology. My first degree I started was biotechnology. And then I switched after the first semester. I was like, oh, no, I don't want to do that. So I actually took a little bit of a circuitous path myself. So my undergrad degree is in physics and maths. It's not actually in astronomy or astrophysics. That was partly because of what was available to me at the time. Like as a first generation college student in Australia, I couldn't afford to move interstate to where there was a university that had astronomy majors. So I had to go to my local university, which only had physics and maths. But I did a really interesting degree there, which is called a Bachelor of Science with Advanced Studies. What that means is like a normal Bachelor of Science degree, but every semester you got to do a research project with a different faculty member in a different lab across all of physics. So I got to do all of these little neat projects in all of these different areas like optics and solid state materials and lasers and very cool stuff. And it really kind of helps me work out what I enjoyed, what kinds of problems I liked solving. So that's like not a traditional astronomy path anyway. But then, people go and do computer science, CS degrees. Those are super, super useful because so much of the field is moving towards analyzing big data sets. So astronomy is moving towards like bigger and bigger telescopes, bigger and bigger surveys, bigger and bigger data sets. It used to be that a gigabyte was a lot of data. And now, it's not even that a terabyte is a lot of data. A petabyte is a lot of data. So we need people with computer science skills to actually help us analyze it, right? Like, I don't know what to do with big data. I don't know how to optimize my code so that it can handle a petabyte and not just like melt my laptop for a week. So that's another like really important path in. Another important path in is communication. So we mentioned earlier that I really like science communication. And that's because I feel like scientists really do have a duty to give back to society, give back to the community that's around them. I mean, scientific knowledge shouldn't be hoarded, it should be shared. So, another real advantage is if you come in with some kind of communication, writing, that kind of background as well. That's a super important skill. Nobody tells you science is all writing. You're just writing all the time. You're writing proposals, you're writing papers, you're writing emails asking for things. Like it's writing all the way down.
That's really good to know. And, I definitely would have to agree. Space is so interdisciplinary. I don't think that there's one degree that makes it or breaks it for any career, especially in something as flexible and open like the aerospace industry. So thank you for those insights. And, you were saying how you switched from biotech into physics in college. So I'm curious, how was your passion for astronomy and specifically astrophysics, or maybe even more specific, a step further into exoplanets, really ignited? What was that moment?
Yeah. So, I mean, when I was in high school, I had a new physics teacher. He was fresh out of university. He was still like really enthusiastic and full of ideas, which was adorable. And he had a telescope and he brought it to school. And because I was in his physics class and he was just explaining stuff to us. And I was like, we need to form an astronomy club. So we started the school's first astronomy club. It was only like 10 girls. But I lived out in the country where it was really dark, so not out of the city. So we would take the telescope out to my property and watch meteor showers and look at the planets and all that kind of stuff. It's so cool. So I knew I loved astronomy, but I didn't know that astronomy was a job. I didn't know that you could get paid to do astronomy. So it wasn't until I was actually at university having my whole crisis about biotechnology that I even realized astronomy was an option. And that's when I looked around and was like, oh, but this university doesn't have astronomy as a major. And then I looked into some of the other universities and realized I just wouldn't be able to afford it. I wouldn't be able to make it happen. So I realized, a degree in physics and maths is a really good foundation for an astronomy degree because, astronomy is applications of physics and maths, basically. So I was like, okay, I'll stay here. I'll switch from biotechnology to physics and maths. I'll do my physics and maths degree. And then after that, I'll do astronomy. So the degree that I was doing, that Bachelor of Science with Advanced Studies, in the third year, there was one astronomy subject. And I was just basically like holding out for that the whole time, doing all of this like, electromagnetism and quantum mechanics and linear algebra. I'm like, astronomy. And then when I finally got to think about my PhD, when I'd actually be able to do astronomy, this was just when exoplanets were starting to really get discovered in bigger numbers. So it was the early 2000s. So, there were a few dozen that were known and more were getting found. And there was this real, Wild West sense of discovery about it, right? Like these were brand new things that we were discovering. And so that had like seeped in. I knew about exoplanets. And then Australia actually does a lot of astronomy in Antarctica. So Antarctica is actually quite a good spot for astronomy because it's very high and very dry. The air is so cold, there's no moisture in it. And that's what you need for good astronomy. You need like a dry, very, very clear atmosphere to be able to see through. And also in Antarctica, the sun sets for 6 months and doesn't come back. So if you want to look in the night sky, you've got 6 months to do it. So that's actually pretty neat. So I emailed around when I was looking for a grad school program to say like, hey, I'm interested in exoplanets or I'm interested in Antarctic astronomy. Like what kinds of projects is your department going to be working on? And one of the professors emailed me back from the University of New South Wales and was like, oh, we're about to start a transit survey from the South Pole if you're interested. And I was like, oh, that's my project. I want to do that. So I got to go to the South Pole and search for planets. We didn't find any, but they still gave me my PhD. So that was good. So, a note for younger players, they'll still give you a PhD even if you don't succeed in doing the thing that you tried to do, as long as you can show what you tried to do and why it didn't work.
That's so incredible to hear your story. I saw a lot of like similar parallels to when I really fell in love with physics and space as well. And it was through a middle school rocketry club. And I feel like clubs have such an important, school in general has such an important, role in our like discovering our passions and hobbies if we go beyond the classroom. And so I'm
Mhm.
really glad that you were able to have that energetic teacher really bring out that passion in astronomy you have. That's
Right.
awesome. And did you have obstacles? I mean, of course, you had the one where your undergraduate program near you didn't offer the specific program you wanted. But were there any other obstacles once you came into the industry? And if so, how were you able to overcome those obstacles?
Yeah. So besides not being able to do the undergrad that I wanted, I would say the next one, kind of chronologically, is being a student in Australia. I was very disconnected from many of the big astronomy institutions around the world, and also a lot of the astronomy culture, like when things happen and how things happen. And, the saying, like, it's not what you know, it's who you know. So I didn't know anyone. And I remember talking with some of the other Australian grad students about almost all of the postdocs. So that's the short-term research contract that you have after you get your PhD. If you want to go on in academia, it's called a postdoctoral research fellowship. All of the postdocs were in the US or in Europe. And I was really struggling to work out how do you apply to them and what are they looking for? And I didn't even know what the job cycle was. Like, now I know almost all the jobs get advertised in like October, November, December. But I was here in May in Australia, like, geez, there's not many jobs right now. So I ended up applying for some random jobs and didn't get them. And partly because I just was scrambling and kind of scattered and just like, I don't know, here, do you want to hire me? I don't know. So then one of the other grad students had done this really, he'd gone all international, given all of these talks at all of these departments, and with his goal of like meeting a bunch of people, right? And like networking and getting his name in front of people's faces and asking them like, how does this work? And what do you do? Anyway, so by the time he came back, he'd already like landed his dream job. And so I was talking to him and I was like, oh my, like, you're so lucky, like, well done. Like, you worked really hard. You really nailed that. And he was like, well, what's your dream job? And I was like, oh, working at Harvard with David Charbonneau. So David Charbonneau is a professor at the Centre for Astrophysics, and he had done some of the really big firsts in exoplanets, like the first transiting planet and the first detection of an atmosphere of a planet, like all these really cool things. And he was at Harvard, which, when you live in Australia, Harvard, it sounded just so grand. And so I just kind of like put it out there. And then the next month, he advertised a job with him. And I was like, that's my job. So, and then I like, you have to imagine like the scene from the Matrix, like, and then I was like, what do I have to do to get this job? So I like emailed everybody I knew, like, do you know David Charbonneau? Could you write me a strong reference letter? Like, I knocked every door, I shook every tree, like, to get my references. I got like heaps of people to read my cover letter and my CV, like, it's gotta be perfect. And then I got the job. So that was really cool. But it was really like this obstacle of just like not understanding how any of this worked. And just having to be like, oh, let's try and work it out. So yeah, now one of the things when I have students, it's called the hidden curriculum, where there's all of this information about being a student and how you move on to the next level that isn't taught as part of being a student, right? Like, you come and you learn physics, but you don't know how to apply for a job and how to interview and all this kind of stuff and who to talk to. And, oh, did you know that internships are important? Oh, did you know that summer research projects are important? Like, all that kind of stuff, the hidden curriculum. So now whenever I have students, I'm like, here's all of the stuff you need to know, because I didn't know it when I was a student, and it's really important.
That's awesome. I mean, first off, thank you for sharing that information for students that are listening. I mean, as a student myself, I've learned over the past year the importance of like networking and meeting individuals who are doing similar careers or maybe have like a similar passion as me, because I've been able to get various research experiences and internships through them, like you were mentioning. And without ever like talking with people, I would have never gotten those opportunities, and I would have been in my little
bubble. How are you
bubble.
supposed to get that information by osmosis? You're not. Someone needs to tell you.
Exactly, because both my parents are not in the industry as well. And so when I got into this, literally the place that I would go was LinkedIn. And it was like my savior, I guess. And it's the place I still go every day just to connect with people. And it's amazing. Just like even speaking with remarkable researchers like yourself, it's really awesome to be able to just hear your experiences, learn from them, and just like be able to share that with others as well. It's awesome. So, I mean, first off, thank you for sharing that and also taking your time to really do this.
No worries. It's my pleasure. Again, I want to make sure people know that there are things that they should know. Right.
Yeah. And my next question for you is a little bit related to specifically more of the space industry. And so since you've been a part of the industry for a while now, I'm sure you have insights that you're excited about and maybe some things you're a little bit reserved about. So my question for you is, what makes you excited and what makes you nervous about the future of the aerospace industry? It could be related to astronomy or not, but
yeah. Something that makes me excited is that every 10 years, the North American astronomy community gets together to write the decadal survey. So the decadal survey is basically, it's a survey of all of the astronomers in the USA and what they think is the most important priority for the next decade. Like what should people be building and what technology should people be thinking about and what models should people be developing and what's the most promising, avenues of exploration. I'm really excited because that's coming out next week. And we've been waiting for a decade since the last one. And this one has been delayed because of COVID. So as a NASA employee, one of the things I'm really excited about is to see what kind of priorities people lay out. The reason it's particularly exciting is for this decadal survey in particular, they did something a little different, which is that they commissioned studies of 4 big flagship missions. So a flagship mission is something like Hubble or Spitzer, an amazing telescope that costs billions of dollars and is really the focus of NASA's efforts for a long, long period of time. So they commissioned these 4 studies. So there were 4 different very cool, very exciting, incredible instruments, which if any of them get built, will revolutionize astronomy. So there's an X-ray satellite, there's an infrared satellite, and there's 2 big mainly optical telescopes that could hunt for Earth-like planets and actually take pictures of them, of planets like the Earth, which is wild to think about. So next week, we should find out whether the committee that commissioned all of this information and read all everybody's reports, what they've recommended. So that's really cool because that will really define the next 20 years of what I work on. Which is really cool.
And what do we search up to find that information? Because I'm curious now.
Oh yeah, so it's the National Academy of Sciences Astronomy 2020 Decadal. And now you know it's late because it's October 2021. But it's the Astronomy 2020 Decadal Survey.
Got it.
And it's going to come out next week.
I'm
very excited.
Yeah. And so on the other hand, the flip side, what makes you nervous?
Oh, what makes me nervous is kind of unregulated privatization of space. And I see the good things about, internet for everybody and that kind of stuff. But the fact there's no regulations and the fact that so much of it seems to be tied up in ego is alarming. So for instance, these big mega constellations of satellites that are being launched like Starlink and OneWorld and stuff, they're so cool. You can watch them in the sky. This train of bright lights go across. It's wild. The problem is there's going to be like 10,000 of them at minimum, if not more. And so now imagine me, an astronomer on the ground with my telescope, trying to take like a 1-hour integration of like the faintest galaxy that's ever been looked at. And then 10 spacecraft just go vroom, straight through the image. It's like, so that's going to really complicate things for astronomers. And it's not insurmountable. There are ways to filter these out and stuff, but it does reduce the productivity of many observatories in their upcoming surveys, which is going to be a bummer. And it's more the fact that no one was consulted before it was all started. And it's like, oh no, you're going to ruin the night sky for all of humanity. And you didn't have to check with anyone, really. So, now there's this whole thing like, the International Dark Sky Association, people who are basically trying to protect the night sky as a commons of the people, right? Like everybody deserves access to the sky and the beautifulness of the sky. It's so gorgeous. I mean, that's why I fell in love with astronomy. That's why I'm doing what I do today, because as a high school student with a little telescope, I fell in love with the sky. And I don't want to take that opportunity away from the next generation who just, they're already losing so much sky with all of the big cities and the light pollution. But now to just like crowd it with satellites it feels a bit insane to me.
Wow, yeah, that's definitely a very unique perspective. And now that you're actually saying it, I've never thought about it like that before, but it does make sense. It's a very unique perspective. So yeah, that's really a nice way to think of it. I understand the importance of commercialization in space, but regulation is also very important, and keeping track of what's being sent to space, how we're impacting not only our planet, but outside of our planet and the footprint we're leaving. I think definitely regulation is essential. So very unique perspective, which thank you for sharing that.
Oh, no worries.
Yeah. And so my last and final question for you to wrap up both your journey as well as some incredible work that you've been doing is, what advice would you give to young students regarding their pursuit of a passion in the space field, space, STEM industry, really anything that they want to pursue, something that you wish someone has told you when you were in middle or high school?
Yeah, I guess, it sounds a bit trite, but almost anything you love can be turned into a job. I guess that's the part I didn't realize. Growing up as a kid, I had, my mum started out as a bank teller and my dad was a bus driver. And I think neither of them really understand why I get paid to do what I do, because I bring no value to society as far as they're concerned. I make no money for anybody. I provide no service for anybody. They're very confused. But, one of the things I realized when I became a student was that there's so many jobs that you just don't even know exist. Like, figure out what you love. That's the hardest part. Figure out what you love, and then work out what the job is that lets you do that. What's your passion? Then that passion is almost certainly a job.
I would have to 100% echo that. I mean, I'm just in high school, but when I put my two passions together, which was medicine and space together, I for a solid 2-3 years was like, this is not real. This is like, doesn't exist. And I searched it up, and space medicine was a real thing. I just took that step and just like believing in myself and searching up those two words together and realizing it was a real career just like blew my mind. And so like ever since then, I was like fixated on it. So I have to agree, find your passion, and I'm sure there's a job out there. And if there's no job out there, you can create the job. So,
become the job, make the job happen.
Exactly. So I want to thank you so much for sharing your advice and exciting research. I'm also super excited to see the first image of another Earth 2.0. I think that's going to be very exciting. So yeah, thank you so much for your time.
Oh, no worries. Thank you again for having me. And if you have any more questions, let me know.